Hello everyone, today is December 5th, 2025, and we're gonna look at this Leetcode 277, find the celebrity. So the description is kind of long, but the idea is pretty simple. Basically, you are given like a from n number, so the people index from 0 to n minus 1, so they are like a n number there. And the system gives you a nose function, so this will tell you a boolean. It means does A, if A knows B, then you will return false. If A doesn't know B, you will return like if A knows B, you will return true. If A doesn't know B, you will return false. So basically, we want to find the celebrity among these people. The celebrity knows nobody, and everyone else knows the celebrity there. So let's see how we can do it. So basically, the idea, it's like we're gonna do like a loop first. Let's initialize a candidate. Just pick number 0 to be the candidate, and then probably do a for loop, like for I in range length of n. So this would go through like a from actually let's just from the range from 1 to n. So since 0 is our current candidate, so we just need to check people from 1 to n minus 1. So this range will give us like an exclusive range from 1 to n minus 1. So if like we can call the nose function. So if the candidate knows I, so the celebrity should know nobody, but if it knows this I, then it's guaranteed that the candidate is not a celebrity. So instead, we pick I to be the next candidate, and then just keep repeat. So if like it knows someone, then it's out, and the next person would be a potential candidate. So after this for loop, we have like find a one person. That person may or may not be the celebrity. So because like in the question here, I think there's a case that there's no celebrity case here. So 0 knows 2 and 2 knows 1 and 1 knows 0. So there's no such a case that like 1 knows nobody else there. So we cannot like rule out the case that I knows nobody or no everybody knows I. Then we need to have like a second loop, basically to verify that I is indeed a celebrity. So what we can do is like from I in range, let's do it again, from 0 to n. So this one is checking everybody. And then if like so in the question here it says like if there's no celebrity, we should return -1. So here we're gonna check if there's any violation of the rule here. So if knows, so here we should set the candidate to I instead of set I to be the candidate. So this is like we update the candidate. Yep, so after the first for we have the candidate. So now if we only have a single candidate. So if the candidate knows someone, then it's not a celebrity. There's another case. If someone doesn't know the candidate, like I does not know the candidate, then this is another case that the single candidate is not a celebrity. But after the second for loop, the verification loop, if we don't find anything violates the case, then the single candidate would be the celebrity that we're looking for. Candidate. Yeah. So let's check if we can pass the test. So a small test. Oh, got wrong. So let's check here. So this is the input as the first case here. So if candidate knows I, oh here, we need to exclude. I think we need to exclude the candidate itself because in this for loop, we are checking every single candidate there. So if a candidate calling itself, I don't know what would happen there. So let's say if I equals candidate, we should continue. Skip that. And if you can get to here, that means I is not candidate. Then we can check, does the candidate know any other person? If he knows it's not a celebrity, or if there's someone else doesn't know the candidate, then it's not a celebrity. So let's try a small test. Yeah, it passed. And the big test also got accepted. It beats like 77% of the solutions there. So let's look at the time and space complexity. So for time complexity, this for loop is like O(n), and for here it's also like a O(n minus 1 excluding itself there. And we need to compare choice. So it's like 2 times n minus 1, but it's still O(n), still linear. So linear plus linear is still linear. So the overall time complexity is O of n. And we don't use any extra space in this case there. So the space complexity should be O of 1. If you found this video helpful, please smash the like button. It really helps support the channel. And don't forget to subscribe for more content like this. Subscribing also helps the algorithm recommend similar videos to you. Thanks for watching, and I'll see you in the next one.